Alrighty. Another day. Oop, that's not what I want. PD.com, HBO, PGL. Alrighty. You got this one is an ACT question. It's a high numbered ACT question. So I'm going to give you, like you would have on the ACT, 1 minute. Let's see. Oh, we're all over the place. Appears the D is the most popular choice. Oh, that's because it's right. Yeah, okay. All right, let's go over how to do this. So this is a rational function, right? It's got a fraction with x in the denominator. As a result of that, we know that the only numbers we can't plug in for x are the numbers that would make this denominator 0, right? Because you can't divide by 0. So we know x cubed. Oh, wait, hold on. D isn't right. Oh, this is a tricky one. Oh, D is not right. Oh, ho, ho. Because that's a cubed. It's a cubed there. Okay, hold on. I mean, one more version. The old cubed there. It's a good thing I went over this one. Okay, so we know x cubed minus 9x cannot equal 0. We can solve this for x by factoring. The first you should notice is that they have a common factor of x that we can factor out, leaving x squared minus 9 cannot equal 0, which means x cannot equal 0 and x squared minus 9 cannot equal 0. So already if you got to this point, you got a 50-50 shot. It's D or E. If we solve this for x, you would add 9 to both sides, so x squared can equal 9. And then we would square root. And x would be, cannot equal plus or minus 3. Because remember, the rule is if x squared is equal to some number c, then x is equal to the plus or minus square root of c. Is that fun? Or another way you could have done this is instead of setting this as a separate equation, this is still factorable. X squared minus 9 is a difference of squares. So you could have said instead for your next line here that x plus 3 times x minus 3 couldn't equal 0. And then that gives you all three. 0, -3, +3. E. Okay, okay. I was gonna look how many people put E initially, but then everybody's like, change this answer. Get out of here. That's okay. It's not for a grade or anything. And if you didn't get it, you shouldn't feel bad. This is question number 47. So if you remember how the ACT works, right? The first 10 questions are the easiest, the last 10 questions are the hardest, and it progressively goes like that. So as you go through the test, every additional question you do is on average harder than the previous ones. So this is 47. So if you think, here, let's do some math. 47 out of 60. What's the new high score on the ACT? Is it like 36 is the highest you can get? So if we solve 37, whoop. 47 times 36 divided by 60 is a 28. So this is a score that you'd want to get for a 28. Okay, no, 47. I say that, but it's actually, that's approximate. It's probably more than that because that assumes the scores are linear, which they're not. They're follow a bell curve. So if you want a 21, then you want to get 30 questions right. But then after 30, it kind of clumps together. So I'm guessing it's like from 25 to 35, you're really close in the middle here. But then after like 35, you getting one more question right can really move you along to a higher score because it's curved or it's normalized. Okay, questions about this?
What would 35 questions right on the ACT give you?
35. See, I say that. Okay, this is just an approximation. This is not, and it also depends on the individual ACT too, because you know, some ACTs they say are harder than others, so a 35 gets you further. Some ACTs they say are easier than others, so a 35 doesn't get you as far. This says 21, which is not true. It would be like, because 21 is average, so it'd be like, maybe if we had two, it'd be like 22 to 25 range. And I bet you if you get 47 right, you're really looking at like the 29 to 32 range.
Well, the reason why I asked is because I'm in ACT prep and we were going over the math ACT, which I'm going to be talking to you about on Friday.
Yeah, I'm going to be there Friday, 6th hour.
Yeah.
That'll be fun. That's always a fun class. I like that one. Okay, there's some other stuff that I was going to show you. Okay, let's clear this. All right, student view. So this is, if when you log into WebAssign, this is what yours looks like, though probably not today. Yeah, there's a new homework today, 1.4. Let's do Monday. But okay, I found the videos. So if there's ever a class that you miss and you don't want to watch 90 minutes of this class, there is alternatives that you could do. Down here, you hit resources. There's only one that you could open, our pre-calc textbook. Chapter 1, and look, there's a video over every section. And when you go to that, there's a video on each part of the section, right? So if you're like, the only thing I was doing bad, I don't know, is after today's lecture is the reflections. That's the only thing I don't get. Then you could watch a video just over reflections that's like 2.5 minutes long. Isn't that wild? It's like you don't have to search YouTube for a video. You could just get a video of exactly the part that you want to talk about. And that's what we have, what I've got on November 9th. That's your assignment is going to be pretty much read the textbook, Then go watch the video over the sections. Go watch all of them over. Will probably be here. Go watch all of them over this, like 3.3 or 3.4. Do the homework. Profit. Okay, the other thing I want to make sure everybody saw is when you're doing the homework, if you do not get this done by Monday, then right here is how you ask to turn stuff in late. This. If you want to, I think I've already fixed that for the previous assignments, but you could go back to your past assignments and do the same. Boom. Boom. See that? You see it? Isn't that cool? This is a great website. I really wish I had this for geometry and for AP Calculus. Or the Pearson's website, what do they call that? Math Lab. Math Lab is good. Actually, Math Lab is better. But whatever. Okay, I think that's it for announcements. All right. I suppose you could do that with the quiz too. You could request an extension if you didn't get it done in time. And then I could give you, I don't know, half credit to finish whichever ones that you didn't get done. Hopefully everybody got the quiz done though. All right, here's what we're doing today. It's a transformations lesson. So we've already actually done a parent functions. We're gonna figure out how to do vertical and horizontal shifts. I forgot to shut my door. Reflections, and then dilations, or non-rigid, or stretches and shrinks. Those are non-rigid. They change the shape of the graph. Okay, this is in your notes before. These are the 6 parent functions. You're going to want to go back to these notes. It's also on page, it's on the very start of this section, 1.4, very first page, 41. You might want to refer back to that as you're doing the homework problems frequently, because all of our transformations is going to be a transformation from one of these 6. Too fast. Okay. Oh, why is the formatting on that so silly? Whatever. Okay. So if we want to shift one of those graphs to the left, right, up, or down, here's how we do it. We're going to use a positive real number C. A vertical and horizontal shift in the graph of f of x are represented as follows. If I take f of x and I add c to it at the very end, so I just tack it onto the end of the function, it will move it upwards c times. Minus, move it downward. This is the thing that messes people up. If you get something wrong on the quiz next week, this is probably going to be one of them, right here. If I want to move it to the right, then I have to do f of x minus c. Where wherever I see an x, I replace it with x minus c instead. Okay? And if I want to move it to the left, that's when I do positive c. It's the opposite sign than you would think for horizontal. But hopefully, I mean, it should make sense if you think about it. If I plug in 0 for x, right, I won't get the value for f of 0. I'll get the value for f of 2. Right? So where I would normally plot x is 0, I'm going to plot the point that was actually used to be 2 to the right of it. So I'm moving that point that used to be 2 to the right, and I'm moving it to 0. I'm moving it left to 0. Because I can now get to those higher value x values faster because I've added c. So, for example, you know, if you had like So this, if we were thinking about rationals, this could be like 1 over x plus 5. That would move it up 5. 1 over x minus 5 would move it down 5. And then 1 over x minus 5 would move it right 5. And 1 over x plus 5 would move it down 5. Where the difference is, right, is that extra number we're tacking on at the end of the function, or is it inside the function itself, under the radical in our case here? Okay, while you're writing, I'm gonna go shut my door. Oh. Oh. I didn't get coffee this morning. It's a problem. Do you think third hour would care if I said, all right, let's go on break for 20 minutes? Just put your questions in chat. I'll get to it. And then I mute myself and cut off my mic and then go to Dylan's and get a coffee. You think they notice?
I don't think they'd care.
You don't think they don't? You don't think they would? Most of them wouldn't have heard the announcement to start with because they would have, started their Zoom and then walked away, playing on their Nintendo Switch or their Xbox. You all are funny. Okay. More time to write? Are we good? Okay, nobody's telling me, no, Mr. Lake, wait. So let's do it. Okay. So, for example, if I want to graph each of these, I could do it without a calculator. I mean, of course, you could do it with a calculator. You could do it by point plotting, right? You could do it with all that stuff, but I could do it without a calculator because originally I know that a cubic function looks like this. Right? So g of x is that same function just moved down. 1. Whoop. Easy peasy, right? Because again, the -1 comes after the function, so this means it goes down. 1. This one, because the -1 is inside the function, makes it go right 1, not left 1. Remember, it's the opposite sign of what you would think. So I'll just slide this to the right from my blue parent function over there. What about this one? Oh my gosh, it's got 2. So since the +2 is inside the parentheses, it's being cubed as well. That is going to make it go left 2. And then the +1 tacked on at the end that happens after our function proper makes it go up 1. So I would go left 2, up 1, left 2, up 1, left 2, up 1, and so again, I'm doing all of these by hand because I know what a cubic x, what f of x equals x cubed. I know that graph. I know the parent function. I know it goes through -1, -1, 0, 0, 1, 1, and it has this, weird curvy thing, right? As you do more and more of these, you'll have all the basic parent functions memorized, what points they go through. Like I know it goes through 2, 8, and -2, -8. But if you don't, there's that page 41 has the basic graphs that you can use. Also, you can always just go on Desmos or use your TI-84 to graph it if you're not sure what it looks like. They will kind of use that against you, at least on the ACT, because they budget in 1 minute per question. So they're going to assume when you're taking the ACT that you have the parent functions memorized and what the transformations do. So if it asks you to identify to either identify the graph of the function or to write an equation from a graph, they're going to expect you to be able to do that by hand really quickly and under a minute. And if you have to use your calculator, then, they're going to hit you with the time. You'll get the right answer, but it'll take you generally longer than a minute to do it. Let me see. Are we good to clear and move on, or does somebody need more time? Okay. Let me show you something. I just want to make sure that this works the way that I think it will work. So on the homework, like for this, sketching the graphs of the functions, these are all quadratics. So I'm going to click this one, double click, and then I know this is going to shift it to the right one. So it would normally start at 0, 0. Instead, it's going to start at here, and then it would normally go through 1, 1. So instead, it'll go through 2, 1. And then you only, just like for the lines, you only need to plot 2 points to draw your quadratic. Okay? And I don't think it does it for you for anything other than the quadratic, the one that you have to graph by hand. But it's just like you're graphing by line. You need to know 2 points that are on the quadratic. And once you know 2 points that are on the quadratic, you can graph it by double clicking this. And I think you could change the points over here if they're not exactly what you like. You can also make it a dashed line. Ooh, look at that. Okay. All right, happy? Fill. Okay. Ooh, now it's a cup full of apple juice. Okay. All right. Boom. Your turn. So graph or use the absolute value function f of x equals the absolute value of x. It's the one that looks like a V. To graph this, g of x. And go ahead, you don't have to graph f of x on this, just g of x is all I need. I'll give you 3 minutes. The first thing you might identify is there's 2 things. What does the -3 and -5 do? And then do it. Do it. Okay, pretty much everyone that's responded has gotten the correct answer. This would, the -3, I'm actually really impressed. Nobody said right, or nobody said left. Everyone said that moved it right 3. And then the -5 would go down 5. So again, this is the parent function, which I'll do in blue. This is f of x. It's the v, right? Because you think it's, I don't know if you've seen this before, if this is how it was explained to you before, but f of x equals the absolute value of x is just the piecewise function. 1x. Nope. That's not how I want to do it. -x when x is less than 0, and positive x when x is greater than or equal to 0, right? So it's just a linear function where when x is negative, you change the sign from negative to positive by multiplying it by another negative, right? X is negative, and you multiply it by negative, it'll make it positive. But both of these just have a slope of 1. So this is the graph y equals x, just starting at 0. This is the graph y equals -x, again, just ending at 0. Okay, this moves it to the right 3 and down 5. So if I count, 1 banana, 2 banana, 3 banana, 1 apple, 2 apple, 3 apple, 4 apple, 5 apples. All right. You can tell that I'm really good at drawing lines freehand. Yeah, not too bad. Okay, again, I said that you could do this in your calculator too, if you liked. In Desbos, what that looks like is you have to hit Shift, and it's the key above Enter, has that vertical line. Ooh. Okay, and then -3, -5. Oh, my scale's not right. The scale in here is too big compared to the other one. Okay, but it's, again, the button above Enter, you can see has that vertical line. That's the button you need. In your, okay, I got to stop share to show you how to do it in the TI-84. Does anyone need to write any of this anymore? No? Happy? Okay, stop share. Share screen. Whole thing. Here we go. Where's my, oh, I forgot to, gotta open it. TI-84. Nope. Does this have trial for you all? Or do you just get it? I think you might just be able to have it. I have to have the trial version. Okay, to type it in, you go to y equals, clear out anything you did before, and then if you want to type in the absolute value, you have to hit the math key. Okay, math key. It brings up a whole bunch of functions that you didn't have before. If you go to the number tab, the first one, abs, is the absolute value. Okay, so it's math. Again, this will bring up some, like if you need the cube root or cubing something, or, and whatever x root of something, you can do that all here. Abs, if you need to round something, find the integer, min, max, least common multiple. There's a whole bunch of stuff. I think that helps you find the conjugate and convert stuff to polar or to rectangular. This is your stats. When you do problem stats, you'll learn what all these do. Okay, but you want to go to the number and then hit and then graph and then boom. Oh, but my window's messed up. Zoom 6. There we go. Okay, questions? All right, we're gonna take a 5-minute break. What time? 28. Oh, 7-minute break. 8:35. You have just completed the first cycle of learning. So you got 7 minutes. You could work on the homework if you wanted, or you could just relax. Oh, hold on, actually.